हरि करना।
Now it's time to address the elephant in the room. So that's the conditional probability for dependent events. That's where the fun comes. So conditional probability is the probability of an event A occurring given that another event B has occurred. So it's denoted by P of A vertical bar B and read as probability of A given B. Probability of A given B. So to calculate the conditional probability, we use this formula. Okay. So this is what we do. So conditional probability is the probability that the second event B occurs given that first event A has occurred. A has occurred. I'm repeating it. So the conditional probability is the probability that the second event B occurs given that the first event A has occurred. So that is equals to probability of A and B divided by probability of A. That's what is the conditional probability formula, and that's how we calculate. So given that A and B are events in the sample space, that's the first condition. And second condition, and probability of B is different of 0, it should not be the 0. And then conditional probability of A given B is, this is what we get. Okay. So in this, where P of A and B represent the probability of both A and B occurring together, and the probability of B represents the probability of event B occurring, or probability of A represents the probability of A occurring. I'm repeating again one more time. Probability of B vertical bar A represents probability of B occurs given that first event A has occurred. Then probability of A and B represents probability of both A and B occurring together. Then probability of A is nothing but the probability of event A occurring. Okay. So the idea behind conditional probability is that when an event B has already occurred, or when an event A has already occurred, let's take this way. Probability of B given that A has occurred. Let's take like when the event A, this one, when the event A has already occurred, the probability of B changes. Obviously, the probability of B changes because one event has occurred. When the event has already happened, then you have to take out that one event. You have to reduce one event from the sample space as well as the respective event related frequency. Both places you have to reduce it down because one event has already occurred. So then let's take then the both the things, sample space as well as the sample space size as well as the frequency of respective event happening also reduces. That's what is your conditional probability. That's what the idea behind the conditional probability. I just want to repeat it one more time because it should be very important. If that is clear, you can easily handle a conditional probability. The idea behind conditional probability is that when an event when an event A has already occurred, then the probability of B changes. The probability of B changes because its sample space size changes, its frequency of occurring also changes. That's the main idea behind that. And the most important, it has a wide application range. Conditional probability is an important and important concept in many fields, including statistics, machine learning, and decision making. It allows us to update our beliefs and predictions based on the new information that becomes available. That's where the conditional probability and latter stage Bayesian, these are the kings of machine learning, certain machine learning algorithms.